In this question, the wedge has a mass of 7 kilos. It rests on a smooth horizontal table. One of the faces is smooth, makes an angle of 45. Particle of 1 kg is placed on face and released from rest. So let's see what's going on here. We have a wedge, 45-degree angle, 7 kg, so we just call it 7. We have a wedge of 1 kg placed on top. We'll call the acceleration in this direction A, and we'll call the acceleration in this direction F. And now let's look at the forces. So the particle so we just have M1m or mg coming down, or just g. We'll just call it g in this case. We have my reaction, or we have my angle of 45. I also have my angle of 45 in here. So in this direction I have g cos 45, which is equal to g over root 2. And parallel to the slope I have g sine 45, which is also g over root 2. We need to work out the acceleration along this plane here, f in this direction. Let's see what's going on up in this direction here. So I have my angle of 45 and my acceleration of a along here. So I continue to my right angle. Along this direction I'm going to have a over a sine 45, a over root 2, and they're going to be the same here. In this direction here I'm also going to have a over root 2 cos and sine 45 being the same. So my acceleration down in this direction is f minus a over root 2, acceleration of the particle. So my forces parallel to the slope, the only thing I have parallel to the slope is g over root 2. That's going to be equal to m, which is just 1, times a, which is f minus a over root 2. Perpendicular to the slope, we're going down this way, g over root 2 minus or, because it's not going up in the or direction. There are my forces. That's equal to m, which is 1, times the acceleration, which we got over here in that direction, is a over root 2. Not sure what I need to multiply them by. If I multiply them by root 2, I'm going to get root 2 at the f. So I might just leave it for now. I'll leave it at these two for now. So now let's look at my wedge. And the force is on the wedge, or in that direction. So I'm going to bring my or down in this direction. I'm going to create my right angle triangle going in this direction, where or is my hypotenuse. So along this direction I have my angle of 45. I'm going to have or sine 45, which is or over root 2, and in this direction here or cos 45, which is also equal to or over root 2. The acceleration of my wedge is a, and the mass of my wedge I think is 7. So let me double check. 7. So the mass is 7. So 7 g coming down this way. So let's look at my forces in this direction. I just have or over root 2. So or over root 2 is equal to ma 7a. we need to replace or normally, so we have minus or, so why don't you just get or? What's or equal to? Or is equal to 7 root 2a. So if I go back up here and I put in 7 root 2a, I'm going to get g over root 2 minus 7 root 2a. That's equal to a over root 2. Okay, let's multiply by root 2 to get g minus 7 by root 2 by root 2 is 7 by 2, so 14a is equal to a. So g is equal to 15a, so my a is equal to g over 15 meters per second squared. We need to sub back in g over 15 to find f. G over root 2 is equal to f minus a over root 2, so a is g over 15, g over 15 divided by root 2, so the root 2 goes on the bottom. So if I multiply by root 2, well, I just want to get f, don't I? So I've got g over root 2 plus g over 15 root 2 is equal to f. So that's going to give me, cross multiply, common denominator of root 2 by 15 root 2. Your calculator could just do this for you, but we're going to get 15 root 2g plus root 2g. So that's going to be 16 root 2g divided by 15 2s are 30. So that is equal to 8 root 2g over 15 meters per second squared. No, it's not the answer. Accelerations. Find the acceleration of the wedge and the acceleration of the particle relative to the wedge. And also find the speed of the wedge when the speed of the particle relative to the wedge is root 2. The speed of the particle relative to the wedge is equal to root 2. The system was released from rest. We just got the acceleration to be 8 root 2, what was it? 8 root 2g over 15. I'm going to call that a for now, just acceleration a, or new a. 8 root 2g over 15. So that's what we have in relation to the particle. We're looking for the speed of the wedge. Are we looking for the speed of the wedge? Find the speed of the wedge. So if we're looking at v of the wedge, the system also starts from rest. We have the acceleration of the wedge, which was g over 15, I think. And it was g over 15. So we're not going to be dealing with distance here, so we're going to need time. We're going to need the time taken. Over here, we have 3 variables, so we can get the time taken for the speed of the particle to be root 2. We can put that into the wedge, same formula, and we get the speed of the wedge after that time. So vu at, v is equal to u plus at. Root 2 is equal to 0 plus 8 root 2g over 15 times t. So if we multiply across by 15, we're going to get 15 root 2 is equal to 8 root 2g t divided by 8 root 2g has to be equal to t. So we get 15 over 8g. 15 over 8g is equal to the time taken for the particle to get to that speed. So we're looking for the velocity of the wedge. That's going to be equal to 0 plus a g over 15 times t, which is 15 over 8g. So the velocity of the wedge is going to be, cancellation city, 1 over 8 meters per second.